All right, so we might get started. Thanks for coming along today, everyone. It's my pleasure to be hosting Aurora Torres here today to give the seminar. Aurora is a researcher at the University of Alicante in Spain, and I'll let you introduce a bit more about your background. I'm sure you'll go into that during the talk. But yeah, really exciting to have Aurora here. She's one of the only people in the world who can get sand sustainability, construction materials, and what that means for sustainable development, but also achieving conservation goals. So really excited to hear you talk.
Thank you so much. Yeah, good morning, everyone. Thank you for this very nice introduction. It's really a privilege for me to be here and have admired your work for so long since I started doing mining. So it's really nice to have this explore ideas this week. But since I guess you don't have often presenters from Alicante, I just wanted to give you a very quick introduction to the area where I come from. So Alicante is the city of Spain in the Mediterranean coast. It has two official languages, Spanish and Valencian, which is very, very close to Catalan. And it's an area that has been a strategic location for over 7,000 years. You can tell the influence of different cultures in the city, but also in the surrounding landscapes, because the earth has been moved around a lot to make buildings, and there are so many mining sites active and abandoned in the surroundings of Alicante. So,
could you just speak up a little bit, or maybe stand a little closer to the...
Yeah. Some of the reasons why Alicante is internationally well known is because it's the start port of the ocean race, and it will be for a few years. There is a passion for fire and gunpowder and noise that I don't fully share. But in this time of the year, we have many sculptures in the city made of paper that then completely burned in a ceremony in St. James night. It's something totally worth seeing. And then Alicante is also the city of rice. It comes from the land of paellas, but we don't only have one type of paella. We have like thousands of paella rice styles. Just that is a great reason for traveling to Alicante. But also on the academic side, the University of Alicante is doing a lot of work on restoration ecology. We have the director of the European chapter of the Society of Ecological Restoration, who is now fighting a lot to promote the European restoration law that is being discussed these days. There is also a lot of research on drylands because it's an area that is suffering a lot from desertification processes, and we have one of the best-known researchers on this topic, Fernando Maestre. And touching on the topic of mining specifically, I wanted to highlight a project, the Life Tech Mine project, that recently was awarded with the Citizen Science project, and that is promoting the use of innovative techniques, many of which are being extensively applied in Australia, but are not still that common in Europe. So this is kind of creating a good example that is now propagating to other mining sites in Europe. And now that I enter on the topic of mining, today I will be talking about a sustainability frontier you may have heard about or not. We have seen that the problem with some resources have been gaining space in the media in the last few years. We heard about the global sand crisis, the shortages of sand, or the devastating environmental consequences of destruction. And it's not by chance or because it has just become a sexy topic. I think it's a reflection of how much our consumption of these resources has changed in the last decades, and this is creating sustainability and environmental challenges. So today in my presentation, I will tell you a little bit about my journey and how I went from being a road ecologist to fully immersed in the field of sand sustainability. Then I will present you with some of the global challenges with a greater focus on biodiversity, because I thought you would be more interested about that. And then towards the end, I will discuss several transition pathways that are emerging, and in general, how we can tackle the topic of sand sustainability. But what has been really central to my research over the years is the aim of advancing our understanding of the direct and indirect impacts of infrastructure development on human and environmental systems. And my pathway in academia started with this wonderful species. The great basket is an emblematic species in Spain, And as a PhD student within ecology, I was tasked with assessing the impacts of intensive human land uses, in particular infrastructure development and urban sprawl on wildlife and landscapes. Then after this PhD in the National Museum of Natural Science, I moved to Germany to join the IVID Research Center to work in a project on promoting the ecological restoration agenda of the European Union with a perspective of rewilding, kind of developing methodologies for measuring rewilding progress and also for mapping priorities for rewilding in Europe. But during this time, I was also doing some parallel research. Because just 6 months before defending my PhD, I was attending a conference of the International Association of Landscape Ecology. By then, I was presenting results of a couple of chapters of my PhD dissertation, but something different piqued my curiosity. I heard for the first time about sand being stolen. An entire big beach in Jamaica has disappeared in a very short period of time because a resort was in need of sand resources, and this resource was becoming increasingly scarce and precious in the island. And I remember in that moment thinking, to what extent are we getting as a species that a resource like sand is becoming scarce? And it was also a moment of realization that when I was approaching the study of assessing the impacts of infrastructure development, I was just looking at a part of the picture, just what happened on site, on the construction site. What about the indirect impacts that are emerging from the extraction of construction minerals? So in that moment, I created a working group to start to investigate this topic. And I became really passionate and excited about this research, mainly because of the dimension of the problem. Just to give you an idea, you may have heard that the anthropogenic mass of the planet in 2020 outweighed all of Earth's living biomass. What maybe you don't know is that 90% of that anthropogenic mass is made of sand, rubble, and crushed rock that we use for the foundation of our houses or to produce concrete and asphalt. And most of this extraction has happened in the last 20 or 30 years, to the point that this has become the world's most extracted solid material by mass. And what is even more important is that the extraction is expected to double in the next decades with infrastructure development, urbanization, but also climate change adaptation and mitigation, and changing lifestyles. So this, the dimension of the demand and extraction of these resources is creating significant challenges that we highlighted in our first publication in 2017 in Science. That was one of the first papers that was kind of connecting the dots among disciplines and sectors to fully understand the big picture of what the extraction of construction minerals, in particular sand resources, represents for topics of global interest, such as food security, water security, biodiversity loss, or health impacts. And at the same time, we published an article in The Conversation using the term the global sand crisis to emphasize that part that our relationship with this resource has dramatically changed in the last decades. And it was widely covered by many media outlets. And this research allowed me to get a Marie Curie Fellowship to fully immerse in the topic of sand sustainability. So for the last 3 years, I was coordinating the Sand Links project, looking at the linkages between the use of sand resources, the environmental degradation, and the social and economic outcomes. I was developing that in Michigan State University with Professor Jack Liu, and in the University Catholic of Louvain for the last year with Professor Eric Lamban. And one of the points that we have been emphasizing over the years is that when we approach the topic of sand sustainability, we need to think about 3 crucial dimensions. So the first one is about ensuring the supply of materials for satisfy societal needs, such as housing, industry, and transportation. And the question that the journalists are asking again and again and again is, are we running out of sand? When are we going to reach the peak of sand? And the response to that is actually very simple. We just don't know. And we don't know because there is no global scale assessment that has ever been conducted of the geological stocks under uncertainty. Not even the estimates of the extraction of construction materials are fully reliable. We consider that they are very likely an underestimate. So we cannot really respond to that question. However, geologically speaking, some resources are relatively abundant in the geological cycle in different shapes, and they are quite extended in different parts of the planet. And also it's important to consider that there are alternative supplies of aggregates. We can produce them by pressing a wide variety of rocks, such as basalt or granite. And we can also use secondary materials such as construction and demolition waste. So considering all this together, the thinking of a global sand scarcity seems unlikely, at least for the moment. However, what we are seeing more and more are local and regional shortages emerging in certain places, particularly when there is a rapid or high concentration of the demand for these materials. But it's important to distinguish between the physical scarcity in places that have an unfavorable geology or that have overexploited the resources, and the economic scarcity that is quite often much more common. So the resources are physically available, but we cannot access them because of economic or sociological constraints. For example, the city of London is built on top of valuable deposits of sand and gravel, and there are also issues with competing land uses like nature protection or food production. Now, the extraction of these materials, as every extractive activity, always has a toll on ecosystems. I will talk more about the environmental impacts later, but just to give you another big indicator of the dimension of this challenge is that mining and construction have become the most significant global geomorphological shaping force of the 21st century. Yes, through these activities move around 24 times the amount of sediments that is naturally delivered by the rivers to the ocean every year. So this has been indeed used as one of the indicators that we have entered the Anthropocene. And then we have the social component on some sustainability, and this is quite a complex one, because on one hand, we have benefits, the potential benefits from mining in terms of economic development, of livelihoods, but at the same time, we have the environmental impacts that cascade might affect the provisioning of crucial ecosystem services, such as the protection against natural hazards, food and water security, or health impacts, such as increased prevalence of malaria or air pollution. But as I said before, today I wanted to focus more on the biodiversity side. I'm sure I don't have to convince you that mining has both direct and sometimes more important indirect impacts of mining of species. So I will go straight to the point. And the question is why, despite the magnitude of destruction of these materials, we know relatively little about the burden that it represents for nature. And there are some factors that can explain that. So first of all, there is a wide diversity of sources of construction aggregates. This can be dredged from rivers and coastal areas, excavated in pits, or produced in stone quarries, all affecting different communities and different ecosystems. Then there is also a lack of spatial data, and the global maps that exist of mining sites, and we were discussing before, they barely represent construction minerals, even though by far this is the biggest mining endeavor in the planet. Just in the US alone, there are tens of thousands of pits and quarries, the same in China, and there are really very, very numerous operations in the world. And one of the reasons that explain that is that there are many reporting challenges, as this is a sector, a mining sector that is strongly dominated by small and medium-sized companies, and it's largely informal in many countries. So All this together makes quantifying threats on biodiversity quite a daunting challenge. But we have tried to take the first step towards having an understanding of the systematic of the species that are threatened by mining of construction minerals globally. For this, we did a systematic evaluation with a main focus on sand, gravel, and limestone, and we asked very simple questions. How many species have been reported to be officially impacted by mining? Were higher levels of threats reported, and how is the coverage in high-level biodiversity conservation policies? This is work that is accessible now as a preprint, and another preprint hopefully will be available at some point this week, if I manage. And for this systematic assessment, we used two data sources, the IUCN Red List of threatened species that I know you're very familiar with, and also we look at new species descriptions that in the time of description are reporting conservation concerns such as the mining of construction minerals. And what we found is that in the IUCN Red List, there are over 1,000 assessed species that have been reported to be impacted by mining. 60% of them are in threatened categories, and 4 species have become extinct over the years. And you can see an increasing trend through time in the reporting of these threats. The same happened with the number of newly described species that are reported to be impacted by this activity. And in general, this increased saliency of the threats of construction minerals seems very consistent, even when we consider the increased red list effort that has been done in the last years. Now, regarding the distribution of the species that are reported to be impacted by this activity, we see that they are mainly distributed in a belt that goes from Southeast Asia towards Middle East, Northern Africa, and Western Europe. And the data of new described species allow us to expand a little bit of the coverage of mining threats to other areas that are more poorly covered, such as Brazil, South Africa, or New Zealand. Now, to get an idea of the profile of the species that were reported to be impacted by this activity, we conducted associations, analysis of associations by habitat and by human activities. And what we found is that being reported to be impacted by mining of these minerals is strongly associated with coastal habitats, rivers, and rocky habitats, and also with reports of being threatened by infrastructure and urban areas, which makes a lot of sense because in the end, these are the drivers of the demand quite often, but also threats by pollution, human intrusions, and system modifications such as dams. It's also interesting that we found a substantial separation by taxonomic groups and habitats when we separate the main mining types that we have in our data set. So on one hand, we have the extraction of sand and gravel and the quarrying of rock deposits, mainly of limestone. And in this case, we see that reported threats from sand and gravel have been mainly concentrated on freshwater and coastal habitats, but reported threats of limestone quarries have been more common among rocky habitats, caves, and forests. And indeed, we see that these species threatened by limestone quarrying have lower grain sizes. And this is because in our data set, we have many species affected by limestone mining that are coming from karstic landscapes, many of them with very small distribution, and some of them you can only find them in 1 or 2 limestone hills in Southeast Asia. But it's important to come back to this estimate of 1,000 of the species, because we think that actually this is just the tip of the iceberg. Starting from the fact that the IUCN Red List has only assessed the status and threats of 8% of the species that are known to exist. So making some very rough extrapolations, we consider that the order of magnitude of the number of impacted species might be probably closer to 25,000. So there is a strong data mobilization effort that needs to be done in the next years to try to uncover many of these impacted species and the mechanisms of impacts. And this is one of the directions of my current research. Now let's move into the policy arena. And in this case, as with the threats of the impacted species, we also see an increased saliency of this threat in multilateral environmental agreements. Particularly since 2016, there have been several resolutions by the United Nations Environmental Assembly or the World Congress of the IUCN that are explicitly mentioning the mining of construction minerals in this document. So it seems that this increased saliency is also affecting the policy development. We also look at the coverage of how often are these terms of construction minerals mentioned in global and national targets under the 2011-2020 biodiversity targets. And we found that there are 15 parties that explicitly refer to mining in national targets out of 176. And only 3 mention the mining of sand, gravel, and limestone, which were in particular Fiji, Kuwait, and Nepal. Now, when we look at the national biodiversity strategies and the action plans and their associated targets, we actually see that the reporting of mining threats is way wider. Almost all countries acknowledge these threats towards of mining or include actions towards mining, and almost 46% mention construction minerals. In particular, mentions of sand and gravel are much more common than those of limestone or other resources. We can discuss later about the factors that could be explaining these patterns because we have done some research on that, but it will take time to explain it, so we can keep it for later. And in these works, at the end, we are suggesting a set of recommendations. I don't have time to go through each of them, but they include aspects such as enhancing taxonomic and impact assessment practices, applying the evidence base and advancing this knowledge base that promoting the litigation hierarchy, but also strengthening the engagement and reducing the demand. Because if we do many things, but we keep increasing and increasing the demand, probably these solutions will not work. But there are a couple of them that I wanted to highlight that might be particularly relevant for you. So probably you are all very much aware about how relevant the red list is as a resource and how common it is considered by companies and by different sectors. However, we have the problem of those unknown species or poorly known species for which the mining companies quite often don't know how to react. So something that we are delivering in our work is an advice on how this good practice in impact assessment for those species would look like, in particular for extractive companies moving into areas where there are many species that remain undescribed or poorly documented. And also there are opportunities for increasingly accounting for supply chain impacts of raw materials on financing development projects. We have examined a set of these multilateral and private finance environmental safeguard policies, and quite often these non-living raw materials are excluded. But something like as simple as a wording change, adopting a definition of raw materials that include sand and other construction minerals, such as the one from the World Bank safeguards, could be a valuable leverage point that would contribute a lot of resources towards increasing the quantification of these assets of the impacts of mining on species. So it's another thing that we can consider. And in general, it has become clear through our work that balancing these protection needs with ensuring the supply of materials required designing sustainable pathways at a system level. And this requires shifting the focus from just the mining side to understanding the entire sand supply network of a region as a coupled human and natural system. And this framework that we have developed is informed by theories of socioeconomic metabolism, telecoupled systems, and complex adapted systems. So let's see how these sand supply network framework look like? Well, we consider that there are different dimensions, and a more sustainable use of sand resources hinges, first of all, on a good understanding of the physical system of construction aggregates, which kind of represents the backbone of the system. And to know this system, we need to map and quantify the geological stocks and flows and where they accumulate within a region over time. Just to give you a general idea, this is how a generic material flow analysis for this type of materials look like. And it's quite interesting because it allows us to see all the stages that the material goes from destruction until it is accumulated on the urban landscape, for example. And it also allows us to examine opportunities to modify and to identify alternative supply streams. For example, sand can be excavated from these unconsolidated deposits, but it can also be produced by crushing rocks and also by crushing construction and demolition waste that by itself is a massive problem as it represents 35% of the total solid waste produced in the world. And there are also opportunities to promote a more efficient use of materials that reduces the destruction of primary resources using byproducts of other industries. Daniel Franks has done a lot of research on ore sand, but also using functional substitutes such as engineered timber is becoming very popular in some places. And at the construction stage, there are also things that we can do to reduce the amount of concrete that we need for building, making lighter buildings, and also designing for easy disassembly. That's something that is also becoming very popular. And we also need a spatial representation of the network of the sending system of materials, the receiving system, and the spillover systems that might be affected by this flow, like the transportation routes. And it's important to assess both the economic, the socioeconomic, and the environmental impacts of different supply streams to really identify the best way to deliver materials. And finally, a more sustainable use of some resources hinges on people, on how people decide how much, and which materials to use, because it's a system entirely driven by them, and they learn and adapt their behavior, prioritizing certain deposits, and respond to impacts by developing and enforcing regulations, for example. So they are a crucial component in this system. And the fourth dimension, we consider that is a temporal one, because these systems evolve in time, in space, as complicated systems in response to disruptions such as technological development, supply, bottlenecks, or changing regulations. So if we imagine the stock development trajectory for these materials, we will expect different configurations of these sand supply networks and different transition pathways emerging to to confront different supply shortages that might emerge. In the end, reflecting an increasing complexity of sand supply networks through time, with a possible reversal in the end towards a more circular economy. Let's have a look to some of these transition pathways with some examples where I'm doing research. So this is the Usumacinta River in Mexico. This is an area with very low growth of stocks, very low demand, and where the mining is really artisanal, there are plentiful resources and reduced footprint. For example, you can see as they are loading buckets of sand that they have extracted from the center of the river or from small islands very nearby. And this sand is transported to the stockpiles using the engine of a motorbike that usually children or women are using to kind of help with these mining activities. We just published a paper on gender and sand extraction in the Usumacinta River in case you're interested in this gender component of mining. Now, the picture might change significantly if we have a rapid increase in demand and acceleration, because mining might become more attractive as a source of income, and then it might expand to more numerous and larger sites, mainly taking advantage of the most easily accessible deposits, such as river systems. And in these conditions, we have kind of the perfect setting for supply shortages or local bottlenecks and conflicts to emerge for a variety of reasons, from overexploitation, perceived harms, conflicts with other land uses, and also lagging licensing or insufficient production capacities. And this will force the system to readapt in order to be able to meet the demand of materials, because there is always a way to meet that demand. One of the things we have seen that has happened in many places is the emergence of illicit sand supply networks. And I just want to make a small note here, because when I use the term illicit supply networks, I'm referring to methods involving violence, threats, the overexploitation of communities, or corruption methods. So I'm not including here informal mining, for example. But as I was saying, there are some areas where the increasing mining restrictions motivated by environmental and social concerns have led to an increase in the prices of sand, making it more profitable as an illegal source of income. This is the case of China, that is investing a lot of resources right now for disrupting illicit mining, but it's still a very big issue in the country. Another possibility is the intensification of the extraction process. This is another example from the Ganges River in Bangladesh, where we have seen that in the last 10 years, along an increasing trend in the demand of materials, the stockpiles on the side of the river where the sand is brought after dredging it nearby have become not only bigger, but also increasingly sophisticated and professional as a storage system. And in many places where there are suitable rock deposits available, the initial reliance on unconsolidated sand and gravel might easily shift towards the production of crushed rock. Because although it requires more capacity and more advanced technology, it can deliver a higher volume and a wider range of products, then allowing the mining industry to adapt to the requirements of the changing market. So this is why this has become the main source of aggregates right in Europe, the US, or for example, China has recently made a massive shift to the production of crushed rock. But this is changing impacts from river systems to energy consumption, air pollution, and other associated impacts with these quarries. And as there are more and more restrictions for doing mining work on land, the extraction is also moving towards coastal areas. If you're interested on this topic, there is a report that has been published in the last few weeks or recently in a few months, led by Jean-Baptiste Dufray, particularly focused on this transition pathway. And finally, as we have seen with other commodities, over time and with increasing restriction, it's easy to see an spatial displacement between the production and the consumption sides, in particularly to areas with good transportation links and fewer constraints to exploit these materials. This is common in regions that have a high population density and difficulties to establish new mining operations, such as the case of California. It's not because of a physical absence of resources, but this very long distance transportation of these materials requires more time, fuel, increasing the demands more transport infrastructure, and in the end, it increases significantly the cost and emissions and the bio-invasion risk. So this is why in the end, this is mainly happening between neighbor regions and neighbor countries. It's not like with many other commodities. So with this transition pathway, something that we learn is that this diversification of supply provide alternatives for the system to reorganize and make it more resilient to a spike in demands or changing prices. However, these transition pathways do not necessarily result in the greening of production. And in order to benchmark sustainability performance, we need to look at the trade-offs of different supply pathways. And finally, as we have seen with other resources like fuel, as easily accessible deposits become exhausted, destruction is displaced towards more expensive deposits at greater distances or with increased extraction difficulty. Just before I finish, I wanted to make a small note on a parallel project that I'm doing that is being led by my colleague Zach Sigman, who is a sedimentologist. And Zach is doing a great effort to develop tools to promote the traceability and transparency of sand supply networks by developing sand fingerprinting approaches by combining provenance analysis techniques and image analysis. And if you're curious about this work, he will be coming to Brisbane next week. So I would like to invite you all to come to the sessions on sand sustainability that we will have in the conference on Monday and Tuesday. And with that, I got to the end of my presentation. So massive thanks to all my colleagues and friends that have made this work not only very exciting, but also very joyful. And I want to finish with a quote from John Wins that he said in the conference that changed everything for me. And he said, after all, ecology is just about everything. Thank you very much.